about today is a walk in the cloud with AWS Lambda. And my talk is going to be a little different than probably the talks that you guys have heard thus far, because obviously you're talking about the greatness and the goodness of containers. And so what I'm going to talk about is a little bit of a paradigm shift. This is not in competition with containers, and you'll find as I start to talk, this is in conjunction of the power of the things that you can do. So with that, let's talk about Lambda. So Amazon Web Services currently has two compute offerings. The first is EC2. And if you guys are familiar with anything to do with AWS, you're probably really familiar with EC2. It's our virtual computing environment, infrastructure for rent, if you will. And it allows you to launch a myriad of different operating systems, configure them as you see fit, your environment, your language, host any kind of workload you so desire. And again, you control the infrastructure, you control the language. So again, our virtual server in the cloud. You're probably very familiar, if you are, with AWS with this offering. It's one of our core offerings. The second offering that we have, which we're going to talk about today, is AWS Lambda, which is in direct, not competition, but it is really on the other side of the paradigm than EC2. So remember what I said about EC2? You guys are familiar, you can serve any workloads, there's lots of flexibility. You can really create whatever infrastructure based upon your workload needs you can, and then there enters in Lambda. So let's talk about first why Lambda, and then I'm going to tell you what Lambda is. And I always start off with why, because if you are a crowd that is very familiar with EC2, if you've heard anything about Lambda, most people say, I don't get why you guys created this. And so it's really kind of good to talk about the why of Lambda and then what it is. So Lambda, the first thing it is there is no infrastructure managed. Again, a very different paradigm shift than if you're accustomed to EC2. You focus on the business logic, not the infrastructure. You upload your code. We at AWS and Lambda handle everything else for you. So there's no provisioning. There's no infrastructure at all to manage. A really kind of odd thing talking about a compute service that has no infrastructure to manage. The second thing Lambda is high performance at any scale. We auto-scale, we provision the necessary things to scale no matter what needs you have. In the contrary, if you have very little needs, we provision down for that as well. So automatic scale, but high performance at scale, no matter what needs you have. It's going to be cost effective and it's going to be efficient. Because again, we're going to scale based upon your request. So you only pay, you know how this works, for whatever, only what you use. But again, we're going to match your capacity and adjust accordingly. The purchase of compute is in 100 milliseconds increments. So remember that when I talk about what it is, that'll mean something to you. But again, the why is there's no infrastructure to manage, there is high performance at scale, and the third why is we wanted a solution that you could bring your own code. And if that code was minimal, you just needed a workload to run without having to create an entire solution, you could bring your own code, whatever that may be, and then again, language of choice, you can run. So that's the why. Again, very much about productivity, focused compute platform in the cloud. So that's great when you start off, they go, okay, why, but I still haven't got quite what it is. So let's take a scenario. That always helps, right? Let's take a really simple one. All you want to do is upload some images into S3. And when they arrive, you want those images to be converted into thumbnails for use. If it's web use, it's print use, whatever you want them to be thumbnails. Very simple, execution model. All you want to do is upload an image, have it processed, no more, no less. Or maybe here's another thing. You want to check that some data that you have in DynamoDB, some addresses, are well formed. They have a state, they have a city, that's great. Okay, I can actually use this. And if not, can I correct that symptom? That's all you want to do. These two scenarios, if you really think about it, there's very little code involved in doing that. But if you want to do that today, you're going to have the provision of fleet of machines to do that. Before training those queue, because as these things come in, you're going to need to monitor that queue and have that queue respond when those images hit S3. You're going to have to do that. What about, let's see, you're going to need some machines to actually do the transform. So I want this image to come up. I need it to be converted into a thumbnail. I'm going to need a few images to process that and do those transforms. Well, What about I have to deploy the code that I want to either do those transforms and or to correct those addresses in DynamoDB. And again, depending on where the code should live and what I'm accessing with the code, that may be provisioning even more machines. And then, okay, what if I change the code? I'm going to have to make sure I am doing my due diligence of updating that code appropriately, maybe possibly across multiple machines, maybe possibly multiple times. There's something else I got to think about. How bursty should this be? How much should I provision? How much should I scale? These are things you really have to think about just for these two simple scenarios. What if I need to migrate to a new instance? Now I have to do that all over again and find a migration path. What about the future? What if things change? Not only did I grow, but there are some different APIs and nuances that I want to use. You're going back in and possibly having to reconfigure things on your server and provision that appropriately. So for something that is approximately, let's say maybe 10 lines of code, you've had to go through all of this, and this is at day one. And all I wanted to do was upload a simple image and transform that into a thumbnail. Something that, again, may consist of 10 lines of code. And so there's a disconnect there. The amount of work and effort and compute power you need for that simple solution is a mismatch. So when we thought about Lambda, how can we make you guys more effective, more productive, and not have to provision machines for something very simple, a workload that I just need simply to run with a few lines of code. So the why of Lambda is truly, what if there was a better way to do this? You needed something, and these are requirements that were really considered when designing Lambda. We need it to be easy to author. It has to be easy to deploy. We don't want to lock you into some language runtime that may change over time and it may not be something you're familiar with. It has to be really easy to manage. Again, this is 10 lines of code. I shouldn't have to continually go through everything just to get these 10 lines of code executed. It should be really easy to pay for because, again, this is a very simple scenario, a very simple workload. So these are the requirements and thoughts when it came to why we should create Lambda and what we should do in creating Lambda. So that gives us to the point of, so what exactly is Lambda? And Lambda is event-driven compute in the cloud. It was launched last November at reInvent. And what Lambda provides you with is the ability to just bring your own code to us and have us handle any type of workload you need in your code. It is a stateless request-driven model. The main key that you'll find with Lambda is what we call Lambda functions and triggering on your requests or events. So let's talk about some events or state transitions. Transitions is a great word. You put something into an S3 bucket. I want some code to execute the minute that happens. Lambda can absolutely do that. That can trigger on it and dynamically do that, provision what it needs to do that without you doing that, run the code, and then complete. Again, and you're done. What if you need to just write to a DynamoDB table? You have someone log in and you want to make sure based upon certain logins, and I'll get to some of those other services, that they logged in, they now have access to various things. I want Lambda to process something based upon a write to a Dynamo table. Or I want to update some features they have in my application or a game. They just completed this level. I want to dynamically write that after getting triggered something from my desktop, my server, my mobile device. Kinesis strings are a great example of the power of Lambda. I want to process some data with Kinesis. And once that data gets processed and goes through that stream, I want Lambda to take that data and manipulate it and maybe write to another table. Maybe provide data to Redshift. I can do multiple things now with these streams. And this is not just a stream sequentially that you're using Kinesis. I can literally pick and choose what I want based upon those streams and create either another data source or another application. What if a message comes in a queue? So queues are great, right? You monitor those messages. Well, what if immediately once that message comes in, I want something to kick off and happen with that message to kick off another functionality that should happen? All of these are triggers that can happen. What about a life cycle change happens in EC2? And based upon that change, you want Lambda to execute something, maybe a notification, maybe a log. Those things can now happen dynamically. Lambda executes, and then it completes. You don't have to provision anything for it. You don't have to ensure that, oh, am I using the right runtime? Wait a minute, I didn't update this. I don't have to patch anything. We handle the infrastructure. Because again, this is for very simple workloads. And I shouldn't say that, that's a misnomer. It is for workloads where the effort in putting up a solution, a compute solution, does not match what the execution cost is. So for 10 lines of code, for instance, the scenario I talked about, does it really make sense to issue a full infrastructure to rent that computing time for something that may execute a millisecond at a time and then go away? So again, that was the premise in which Lambda was created, and that is what Lambda is. So if you remember nothing else about what I talked about with Lambda, think about event and request-driven execution at scale without you having to provision any services. So obviously this is really kind of different. We just talked about all these great containers and all these cool things we could do. This is not in lieu of anything. This is in complement to what you can do with your compute power. So this is going to make it easy to transfer data. You can even do auditing, log writing. You can kick off workflows. These are the things Lambda is really designed to do. So a question that always comes to mind once I finish talking about what Lambda is and talking about the scenarios is, okay, is this a Lambda versus EC2 or ECS? When do I use Lambda? What is different than what I already have? I could execute this, rightfully so. Everything I just said, you have the power to do EC2. So here are where the differences come into play and when you should use one versus the other, just kind of considering it. The first thing to remember, as I said, Lambda is request-driven. We execute when something is triggered. An event happened, a transition happened. And once that happens, the request will kick off execution and it will go away. There is no infrastructure rental. So in comparison, if you're using EC2 or ECS, there's an infrastructure rental. You can either use a pre-configured AMI, you can create your own AMI, but there is no infrastructure with Lambda. It is only going to execute on your event, on your trigger. Now, here's something that people most times are like, okay, well that's cool. Does this mean now I should take this paradigm of an existing web application I have running today and run it on Lambda? No. We have great tools to provide a website for you. We have EC2, you have Elastic Beanstalk, we have lots of things that are available that's really targeted for that web service workload. What Lambda is not is, hey, I'm going to reinvent the wheel. This is just another paradigm for I need quick, efficient, scalable execution, and I need it to happen in bite-sized increments and then go away. So the other thing that Lambda is versus EC2 is Lambda prioritizes ease of use. So there's always a trade-off, right? There's ease of use and then there's flexibility. So let's talk about that for a minute. When we say ease of use, that means Lambda is going to have and run on one OS that we're going to manage. We completely control that OS. We completely control the hardware choice of what Lambda runs on. Now, if you don't care about what version of Linux we're running for Lambda and you don't need then you need to, again, bring your code. You need to choose your Linux instance. There are various things you need to run on there. There's specific language runtimes and libraries that you would like to use. Then EC2 is the best option for you. That being said, and I'll get into this when I go into Lambda under the covers, but with Lambda, making it easy to use means you also get to bring your own libraries. But if you need the flexibility to create various workloads, you need to make sure something executes at a certain scale percentage. You need to put a VPC in front of your Lambda, your EC2 starting instance. And there's a reason that you need to do that, and you have the flexibility. You need the flexibility to do that. That's where EC2 and ECS comes into play. However, if you're indifferent to that, and these workloads are able to be executed based upon state transitions, events, or requests, then Lambda is the best choice for you. So again, just some differences here. Lambda is stateless and request-driven. EC2 is compute power that you're renting. You're not renting anything with Lambda. We have complete control in that infrastructure, again, so the OS, as well as the hardware choice, so what instance we're running on, how we're scaling, and versus you guys determining what instance you would like, what OS you would like to run, what flavor of Linux or any other operating system, and what language is your preference. The other thing that's a different thing that you should know about Lambda is its implicit scaling versus direct scale, explicit scaling. So with EC2, you scale by provisioning instances or containers and scaling those. That goes back to at any given time, it could run on. It could be provisioned. Something new could be provisioned to run your code. So again, Lambda stateless is request driven. It is event driven. Again, it's going to respond to state transitions. Any questions so far? Because this is usually the sure.
Just a simple question. So that's Elastic Container. So is the main difference between Elastic Container Service and Lambda has these? Because I mean, Elastic Container Service also kind of just spins up and spins down, right? Like, So it's.
So think about Lambda is not really per se spinning up and spinning down as far as what you want to have spin. If we need to spin something up, it may be that we're only going to take spinning up and spinning down. There may be several requests coming in that it's handling at one time, and maybe it will provision something else if that load gets to be too much. But though it is being triggered by a request. So let's give an example. You have a database that's being written to in various increments of things happening. Certain reads when you detect an anomaly based upon some rules you have in code, you want Lambda to execute something, execute that code. That's all that needs to happen. There is no instance per se spinning up as far as you are concerned. All you know is that your code ran in conjunction with your request in your code. No more, no less. So with EC2, I'm spinning this up because I have a need. It can spin up, spin down. Lambda is only running, and don't think about it as an instance. Just think about it as I am executing something based upon an event that happened. Oh, I know I broke my leg, so I go to the hospital. So it's a cause and effect. I need this database came in. This data came in. I need to process it. Once that finishes, it goes away, which is why it's stateless. Because at any point in time, that server could not be there. It could be handling other requests. Another server could spin up as well.
And just to be clear, and I haven't used the Elastic Container Service yet, so I might just not understand the full picture here. But so when you spin up an Elastic Container Service, I guess it stays running, right? Okay, so that's
you're running the infrastructure. You're controlling the infrastructure.
Right. Okay. It doesn't. There's no way to like. Okay, so it's not going to spin up and spin down super fast because you're telling it to basically keep running.
It's still an instance. Yeah. So think about it this way. When you create an EC2 instance, you pick your AMI that you would like, whether it be whatever operating system, our configured Linux instance, or another one.
Yeah.
After you do that, you say, okay, I want to run a web server. So you may configure Apache on there. Use libraries on there. Whatever, right? As allow a thing to do for one web service web page to the user, right? We're handling. All you're doing is this piece of code. I wrote a piece of code that said, hey, when S3 detects an image, my code just says take this image, run this library, convert it, and then put it back in the S3. And then I'm done.
So like I say, it's just event driven. It's not meant to basically run long running.
Correct. It is event driven and therefore stateless. And so again, I'll talk about, because I'm going to get into the depth of it where you can configure memories and things of that nature. But it really, truly, if nothing else, is event driven. Only based upon a request or a data. Yes, sir.
Two questions. One, all of the events and triggers that you mentioned coming from within Amazon, I was wondering if there's the ability to have events or triggers or communicate with random things on the net. Second question is, I'm wondering what the scope of things you can stuff into Lambda is, and the somewhat contrived example, although I want to try this if it's possible, is can I do something as complex as, say, I want to do a distributed build of something in a traditional compiled language? Can I say, here's a compiler, here's a source file, just do a massive parallel build using Lambda? Is that sort of thing possible?
So there is that sort of thing possible. I know people that are tying Lambda to Jenkins. You're actually very don't into Great. See, yeah.
Is that, okay, then
Maybe I should have waited for questions. Okay. So let me do this. Are there any questions on EC2 or ECS and Lambda versus what Lambda is? Because I'm going to cover that in detail before I move on. No? Okay, so I covered that slide. Now let's get to the good stuff. No worries. All right. So how does Lambda work? So you asked me about, does it respond to AWS services? You're absolutely correct. But Lambda can really respond to any event, any custom event you want. All we're doing is taking your event that you're providing with us information from JSON data and then executing on it. So obviously we've already baked in some things that with AWS services, right? So you can respond to S3 events or DynamoDB streams, which was also something that was announced at re:Invent, or Kinesis events. All of those great things, CloudTrail events, so great auditing types of things, Cognito, so if you want personalization and respond to that. But you also can respond to any custom event. The goal of Lambda is to any service that you need, first of all, AWS, our goal is to be able to have the ability to run those things in Lambda. And obviously we're growing and really trying to get to that any API call in AWS can be executed in bytes in Lambda. So that's one part. The other goal of Lambda as a design consideration is we want you to bring anything you need to exist or execute in a request and event-driven model to Lambda. And so you'll see on my slide here that I have a space holder for custom events. I'm going to go over scenarios. But again, we want to make sure that you as a custom event, no matter what API, and I'll talk about that, that you want to use, you can actually do that. And there are more, again, workloads coming out very rapidly to help you do that. At the end of this talk, you guys tomorrow are going to do hands-on stuff. I'm going to leave a bunch of walkthrough links so you can walk through some of this and get hands-on, okay? But the gist of how Lambda works is an event happens in either an AWS service or your custom application. So whatever that is, a game, a web, a desktop, or server, an event happens that you want to track, that you want to have, based upon that event, a request to go into Lambda and some code to be executed in response to it. So again, obviously we cover all the AWS services, but remembering you can also determine your custom events. Now, how does Lambda execute? Lambda executes those things in what we call Lambda functions. And you can author these in any familiar language using libraries. Now, we just released Lambda, and it just became generally available, I'm skipping ahead of myself, on April 9th at the San Francisco Summit. So currently, we only support, as far as writing in the console, Node.js. But again, you have the ability, for instance, using the Node package manager to load different libraries. Because you have the ability to do that, for instance, let's say, since I'm in the Microsoft building, I wanted to run some C# code in, from Lambda kicking off. There's actually libraries from the Node.js that can kick off .NET code and various other code. I just picked .NET because I'm in the Microsoft building. So you have the ability to do that as well. You are writing a stateless, asynchronous, and I'm going to stress that again, a stateless, asynchronous code execution in what we call a Lambda function. And then it's going to only execute when needed. This is not an instance that's waiting or polling for, per se, for you to, like you have your instance and it's running and it's waiting for a request or web job. It is only going to execute. It's only going to trigger once that event is up and running automatic scale of the need of that execution, right? Then once you do that with your function, your Lambda function, and I'm going to give you a console to show you this, you then can access any server on the other side, including your own custom server. So you can bring in events, you can write your Lambda code. Currently, it's Node.js. In response to those events, and then that function can access any AWS service. I mean, because we actually install the AWS SDK, so that's already pre-configured for you. But again, you also can then access any other custom service you have, and I'll show you how to do that in a minute. Coming in based upon S3 saying a picture that I uploaded, and I want to convert that picture into a thumbnail. Then I could have Lambda do the processing for that, use that conversion, and then put it in another S3 bucket. And I'll get into this in detail, but I'll just say this. Because we're pre-configuring a lot of things for you, we also provide, and this is just as convenient, a graphics library for you in that Linux instance called Image Manager. But you can, because we allow you to load in your own libraries, if you want to load a different type of image magic or any other kind of graphics library, you also can do that as well. That is much more for convenience. But so I can then manipulate that image and then either put it in S3, load it as a blog in Dynamo. I can even then have Lambda respond to the actual transformation of that image and kick off yet another Lambda function.
I might be ahead, and just let me know. You
No
can
worries.
put me off, but so to write the code, first of all, it says any library, so I can put into a Lambda function any programming language.
So great question. Yes and no. We support in the console off the bat Node.js. There are other languages coming rapidly. That's all I'll say.
Okay.
So that you can write natively within the console or from the CLI. So you absolutely can do anything in Node. But let's say I want to run a function that's outside of Node. That's where I was talking about, where I can actually take one of the typical libraries that is an interpreter between Node and, for instance, C#, and have that Node package actually call that code, that compiled C# code, have it execute in conjunction with my Node.js code that's running right now. And if you really want to understand how to do this, well, obviously there's a link, but the Compute blog has a great blog post on it. And I'll also, if I have time, hopefully I'll show you a function that I wrote for Lambda where I'm kicking off a couple of other libraries that does not exist in Node. One does, one does not. It is not in Lambda. I actually created that library by using the Node package manager, using that, calling it from Lambda because I'm bringing my own library and having that kick off something else because I was writing a sample for geolocation.
But you basically have to have a Node library that knows how to talk to that other programming language for now.
Today, you do.
Right, okay.
But many languages are coming.
Something might happen. Okay.
Something might happen. I know. The other languages are rapidly coming, so I'll leave it there.
And so did you choose Node because it's event-driven anyways?
So Node was not only event-driven, it was already stateless. It was the lowest common denominator for most
Sure.
people. So it was just the first one.
Right.
Because it just worked very well.
Right place, right time.
Exactly.
Yeah.
Yeah. So I kind of talked about Node a lot already, but here going to the slide. So the basics. We load a stock Node.js implementation. As I know that the AWS SDK comes with that. Lambda handles all inbound traffic for that. But remember, you can call any AWS service because it's already preloaded. I told you about the graphic library that is available for your convenience. It is Image Magic. Let's say you wanted to compile a different version of Image Magic in a different way. Absolutely can do that again, or bring your own graphic library. Here are the differences. Remember again that Lambda is stateless versus EC2. So different requests may land on different parts of the infrastructure in which we manage. So if you want to persist data, remember this is stateless and asynchronous, you need to make sure that you are using S3 or Dynamo or some other internet storage to persist that data. This is stateless. So while you're executing your code, there is no guarantee that the execution of this code, again, that data will be on that same box because, again, this is stateless and asynchronous. Another thing is infrastructure. So if you're really accustomed to using there is no login. We're handling all of that front end for you. The only thing that you're doing at this point is kicking off a request based upon a trigger. An S3, something came to S3. A data table got updated. Kinesis processed the stream. Some custom event that you determined happened. Some log got written in CloudTrail and we need to wake you up because something bad is happening. Again, you don't log into the box because, again, we're managing the infrastructure. I think that's usually the thing that people who are very familiar with EC2 has, not sure about. But we tried to make this really, really easy, really, really familiar. So you can do things like write to the TMP folder. Now, it will be there while you're executing, but the minute you finish executing, that goes away. But if you need to persist data while you're executing and leverage that, you can write to the TMP folder. One second. And then you can also bring in your own library. But you can use things that are familiar to you, any processes, any threads. We again tried to make this really easy for you. There are only very few restrictions with using Lambda. Again, as far as the processes and threads and various sockets, and again, even bringing your own libraries. Well, the one major restriction that you don't have is, for instance, you're not able to open inbound socket connection because, again, we're doing the front end for you. Yes, sir.
So if I can't log into the box, so the first thing as a developer that I think to myself is, how do I see my application exhaust so that I can debug what's going on? So does this have a sort of implications for how I would go about writing my JavaScript as well?
Yes. Yes, Lou. And I'm going to show you that I was going to get to the debugging of it in a minute. So
I want to stop asking questions. Sorry.
I'm trying to talk fast. All right. So how do you create a Lambda function? I'm getting there as fast as I can. So the first thing I would do when I'm creating a Lambda function is I'm going to pick a name for the function. And then I'm going to pick a memory size. And we're asking for this memory size because what we do under the covers for this is we actually are provisioning all the resources at once. Again, you're going to do this in 64 megabyte steps. So you can go from anywhere from 128 megs to 1 gig. And again, this is your memory size. So as an example, let's say you initially had 256 and you asked for 512. That means you're going to get twice the memory and twice the compute power. Because again, we're provisioning everything at once. This enables you then to have a single dial to tune your price performance ratio. So if you, what we will do is once you run your Lambda function, oh my God, what is all? I have 2 minutes. Oh, I'm going to talk about no.
Keep going. Keep going.
So if you every time you run a Lambda, in the log of Lambda, it tells you how much memory you use as well as how much you provision. So then you can dial up or dial down. Additionally, what we do is we also provide for you error logs and states. Also with CloudTrail, you guys are probably familiar with that. So if you see error rates and things that are happening in it, and I'll talk about the retry in a minute, you can actually say, okay, maybe I'm having latency issues, and then dial that up. Again, the minute you dial up or down, we provision it as appropriate for you. Again, this allows you from a price perspective then is turn down or turn up, and then really fine-tune your performance ratio. The second thing is we're really flexible on the implication path. So you can invoke Lambda either on demand through the CLI or through the console or through some, I don't know if I'm going to get to this, I'm going to say it now, or via one of the SDKs. So one of the new things that were announced on April 9th was that we now support all the mobile SDKs. The PHP new SDK just came out, and some other things of different languages have come out. So you can write, for instance, if you're in Java, I can write a Lambda function in Java and actually have that kick off Lambda. So again, the SDKs are able to write against Lambda as well. So not only can you invoke these now on demand, obviously when I mean on demand, I can go into the console, hopefully I can get there and show you to kick off a quick Lambda function and see the log and information that comes back. But you can also do this with SDKs. I'm just skipping ahead because we still have 2 minutes. You can subscribe to one or more event services. So when you create a Lambda function, the first thing you're going to do is say, what event source do I have? And there are 2 event models. So maybe I get the reader. With Lambda, there is a pull and a push. But I'm going to subscribe to an event source, for lack of a better term. So that could be any of the AWS services, or that could be any of your custom events. how you do your custom events is you create a custom event, and all you need to do is serve Lambda that event in a JSON format, and then that can kick off the Lambda function. Sorry, I'm talking fast. We said I have 10 minutes. You have granular.
I'm also an organizer. I'm going to interrupt for just a moment. We have a 15-minute break after this, so I am I'm going to suggest that you slow down and take your time.
Okay.
We forgo maybe the break. Is that?
Well, let's add 10 minutes.
All right. So.
Okay. Cool. All right, so you have granular permission and control using IAM with Lambda. So you define what permissions your function has. So let's say I'm working with an S3 bucket, and I'm working with this S3 bucket, and I wanted to do that transformation. It can have multiple other scenarios. But I only want it to get something out of the bucket and not put. You want to make sure you still have security going on, right? So let's say I want this Lambda function to only get and list the things that are in the bucket. You actually have granular control and create an IAM role when you create your Lambda function that says these are the permissions and the services it has for execution. So IAM is built in, baked into Lambda. This is not just a free for all here. You, of course, we do the least privilege model. And a recommended permission we always say, and you'll see when you build a Lambda function, it does by default, is to log to CloudWatch. That will be a way for you to check your logs, a way for you to look at the latency and things of that nature. That also it lists all the Lambda functions that you have. It has easy editing of resources, event sources. It tells you at a glance the metrics for your Lambda functions. It also can tell you, because you can execute on the fly and see how well your Lambda function is performing prior to wiring it up to an event. It'll also tell you where your failures are, and you can get immediate response back as well. So really 3 ways. I'm only showing 2 here, but know that all the logs are captured by CloudWatch logging service. You have the Lambda dashboard to be, and I would really recommend it, testing out your Lambda application before letting it free in the wild, because that gives you great information. And then if you're using the SDKs, obviously you have a model of having the try, catch, and debug, and pulling back errors and doing something with it, and therefore either kicking back off the Lambda function with adjustments or appropriate. So again, this is the way you debug here. Now, for real-time processing using Kinesis, Kinesis is a managed service for streaming data ingestion and processing. So Lambda is great for using something to process data. Remember, this is going to show up in order. All data will be stored for 24 hours. The streams are made up of various shards, and that's how we scale Kinesis streams, by adding multiple shards. You can set up Kinesis, so if you're not familiar, to actually ingest data and process data. Then what makes it interesting is then you can use Lambda as this data is processed. Again, your concurrency will be based upon the number of Kinesis shards you set up. It will then cause more Lambda functions to be invoked concurrently if it needs to happen that way based upon the shards, or if you don't have that issue with one. So again, Lambda will auto-scale as appropriate. Each function call reads serially from a shard. And I guess I keep saying that because we've had so many people go, wait a minute, I don't understand. It goes in order. It will do unlimited retries. It's a very different model than, again, the push and the pull. And understanding that is what makes you successful in Lambda. Okay, this is where I do the demo. How much time do I have left? 5 minutes. Okay, so let me just go out really quickly and do the demo.
That's a funny thing.
Wouldn't it be great if AD was on demand like Lambda?
Yes, it would be. Okay, let's see. I have a bunch of stuff up. Well, my proxy server. Let's see. All right, here we go. So let's talk about using Lambda. This is one of the links I'm going to show you. So here's my, I've logged in the console as me. I'm going to go into Lambda. So I obviously this is the dashboard. I have some Lambda functions already. So I have one for my Intel Edison device that I was using for IoT, where it's using Kinesis. I have one for my geolocation. So I have a bunch of different Lambda examples here, right? So let's actually just build one and just do a hello world. And then I'll show you actually one of my functions that's using another service. So I'm going to go ahead and just simply go create Lambda. And like I said, the first thing we would do is say, okay, this is going to be interesting because I just realized I am logged in as me, but I'll just go with it. You'll pick the runtime right now. You guys are only seeing Node.js, so that's the only thing that's there as far as we're all concerned.
Oh, wait a minute, let me get a picture.
That's the only thing that's there. My hello world, I'm going to just keep going with that. Function. So, you write in Node.js, you have 3 options for the Lambda. You can edit the code in line, which I'm about to do. You can upload a zip file that has your code, your node package in it. And what just got released again 2 weeks ago is now you can upload your code from S3. And so you can put literally here where I want my code to come from a bucket, and you can put the URL in the bucket. And when you update your code, it can dynamically update Lambda. So that just came out.
Nice.
This
Can a Lambda upload code for a Lambda?
So
Great question.
you would upload code for Lambda. You would have Lambda call another Lambda function. But yes and no, because now we have the S3. So you upload the code from S3 to run as a Lambda function, which can kick off another Lambda function that's tied to S3. You could really circular reasoning there, but now that we have the fact that you can upload to S3, it will look for that URL and you post new code in that zip file from there based upon this new option dynamically.
That sounds like a really great way to run up a big tab.
What's great about this is the difference in the price. So that S3 loads, but again, 100 milliseconds execute, and those are free. I didn't get to that slide.
Oh, okay.
But the free tier is massive. So you are doing really serious, you're NASA. You're doing something really serious and you get a big deal. I need to come play with you and see what you're doing. So anyway, here's the hello world.
So the unit of deployment here is always a function or a small set of functions?
Correct. So
Yeah.
your unit of deployment is what we consider to call a Lambda function.
Got it, okay.
And again, that can mean various things. So a function if you think about writing code, functions of something very tactical, right?
Got it.
Not so much here, because I can upload a node package that can have multiple different functions,
Sure.
but we call it a function.
Got it, keep going.
Yes. So here I would be writing a Lambda function here. So you'll see the console loading function. Here I have my exports handler. And then it's, again, this is node, so again, dynamic. You're going to respond to the event and the context. So the event comes in, key 1, key 2, and it's going to spit it off in the log because I'm not sending it anywhere. We can have a context fail that writes to the log if something goes wrong, or if it succeeds, we'll echo it back. So here, I'm just going to leave the defaults here. I can create, obviously I have a bunch of different roles for different things, but you won't see this till you create them. But let's say if I was doing this, I'm going to just do a basic execution role. We're just doing a hello manager. As you create different roles for different things, you can reuse them. So like I have a role for my IoT device in Edison that I reuse when I'm testing the various Edison devices. Or I have, you saw a role that I have specifically for my DynamoDB with my geolocation service. So the wireless display is coming. I lost wireless. That'll do it.
Oh, nice.
Let's say come back to me.
It's all right, we believe it.
Yeah, I know. Like I just lost wireless. It's all wireless.
Oh, check to see if it switched Wi-Fi on you.
I'm still here on Cambridge. Right?
Yeah.
Yeah, it's not happening.
Oh, that sucks.
Try relive it.
Yeah,
just keep going.
Okay.
It should get back to you.
Okay, it'll come back hopefully. Let's see. I'll try one time. I'm like, okay, you would do this right when I have no time.
Yeah, give it a second.
Yeah.
I'm like, I have no amount of time,
Yeah.
and now you want to, no internet.
What is going on? No
That
kidding?
sucks. Okay, Let me just disconnect real quick and see if I can.
Yeah.
Ma'am, do you want to log into your account on my machine? See if that works?
No. I can't imagine. Oh, what are you doing?
There we go.
There we go.
Okay.
Let's get-
Yeah. Okay. Disconnect. Oh, God. Maybe it was like she's doing something bad. I promise I'm not. All right. So here. Okay. So here I'm going to either create a new role or use one of the ones here. I'm just going to leave it where it is. I'm just going to say, I'm just going to name this Lambda 2 because I don't know if I've used the number before. Hit allow. You could have viewed the policy document. I just left it as default. So now that I have my execution role, this is where I was talking about you can allocate the memory. So obviously I'm not doing anything big. I'm not going to change this. But this is where, again, it's going to allocate all at one time. You see my timeouts here. So now let's create this Lambda function. Now my Lambda function is created. I'm done with that. Here's my hello world. So I want to edit and test it. Totally advise you to do this. So this key value comes in here. Again, it's going to come through Lambda as a JSON file. So again, I'm just going to do Terra. This is your code running. You can edit it in line. And then you can also change the configuration in advanced setting, blah, blah. So if I say invoke here,
Come on, baby.
no, don't drop me. You'll see that it actually executed. The only thing I'm bringing back, and I'm going to change it so you'll see right now, is the result of Terra, because I'm just bringing back volume 1. You'll see the execution logs where it tells me, because obviously I'm not doing anything. Allocated, however, it tells me what values you look over there have come in. So you saw it says Terra, value 1, value 2. It gives me a request ID and all this information and how long it took. So again, if I wanted to test this to actually be dynamic, again, we're just doing something simple, hello world, which we do this one coming from Dynamo. If I put my last name here, and then instead of saying just writing out this, I write out type P2, because again, this is just the echo function for the symbol. So it should, if I didn't do anything bad, with my typing too fast, it should come back with my first name and my last name. So again, this is just testing really quickly, dynamic. So again, yes, this is, I initially, this is it, now it's in both names. Yep.
I have a question. How is this compared to task queues in App Engine, Google App Engine?
Great question. So we feel like this is very different than most things out there because, again, we're executing the code anything. It's not just I'm taking a queue. You absolutely can tie the queues here with our SQS queue. But this will execute not just in a form of queue and taking tasks. It will execute with anything based upon any trigger. I'm writing processing. An event can happen at random at any time. It doesn't have to go to the queue I executed on. Now, if I want, I also can tie this to SQS. I feel as though it's different, but I'm not as aware of that service enough to comment on it. And it's good or bad, I'm not sure. I am more familiar with the Yep.
Just a quick overhead question.